Welcome back. Today, let's go over the second sequel to my last video, which contains duplicate. This is the number 2 version. I solved this one over a year ago, so let's see if I can resolve it. So you're given an integer array, a list of integers, and an integer k, and you want to return true if there are two distinct indices in the array such that nums of I equals to nums of j, and the absolute value is less than or equal to k. Okay, so cool. So we want to find two equal values with the difference of the indices and the distance less than or equal to k. Cool. So, all right, why don't we just simply loop through the array and answer the question, right? So loop from left to right, and then start another pointer that's going to go to the end of the array. So one place to the right of I, and ask the question if nums of I is equal to nums of j and absolute value of I minus j less than or equal to k, then we can return true, right? And then that's it. If we get through the entire list and this condition never satisfies, then we return false, right? We get through the whole array. And yep. This might time out though, because it's not the most efficient thing. But luckily I have another way to solve it, which is using a hash map. I'm going to show you if this times out, which it does. You get time limit exceeded. Cool. So what's the better way to do this? Well, let's use a hash map. And let's map the values to the indices. So for the index and the value in each iteration from left to right in the array, 0, 1, 2, 3, let's define the key as the index and the value as the value of the particular key. And now let's actually, you know what? Let's make this a default dict list, and we're going to append n, because if there's anything where the two are less than or equal to k in terms of absolute value, then we can already return true, right? Let's print the dictionary to see. Okay, so it looks like, oh no, sorry. Let's do this the opposite way, because we want to measure the distance, and the distance is in terms of the indices. So now now you can see that 1 satisfies this condition, because 0 and 3, the absolute difference of 3 minus 0 is less than or equal to 3. So for k and dict, this is usually better to loop through twice than to do ov(n) squared. And so if dk is, so if the max of d of dk, which is the list of our current key, minus the min of dk is less than or equal to k, let's call this key. We don't want naming errors. Then we can return true. And if we iterate through our entire dictionary and this block never executes, then we can return false. That's correct. Okay. The minimum and the maximum is less than or equal to k. This is supposed to be false. Okay. Oh, and length of the key is bigger than 1, because we need distinct elements. No, that's not correct. Okay. Let's see here. I don't know what's going on. This is supposed to be false. Yep. So, okay. If length of nums is equal to k, bigger than or equal to k, or less than or equal to k, return false. Okay. It's less than k, maybe. No. Let's print the dictionary. Let's use this test case as well. This is a weird test case. K equals to 1. Distinct indices. And length of dk is at least 2, right? I think that's what it should be. dkey is bigger than or equal to 2. See, I'm not sure why that fails, because this is... Yeah, this is... I'm not sure why this is false, because that's true, right? The max of this minus the min of this is less than or equal to k, yes. Oh, no, it's not. Okay. Oh, sorry. dk, absolute value of dk, 0 minus dk, negative 1, assuming that there's, if length of dkey is bigger than or equal to 2. This one has a lot of edge cases. dkey, not k, I keep saying k. That's still incorrect. Okay. Okay. Wow, yeah, that's a hassle, isn't it? Okay. Let's, instead of doing this, let's keep pushing to it. Ni, so that we have it already in sorted order. And now let's say, we can iterate over this perhaps for I in range 1 length of d key. If absolute value of d key of I minus d key of I minus 1 is less than or equal to k, then we can return true. This might time out though, but we'll see. Okay, cool, it didn't. So yeah, that was the key. They like, apparently this is better than O(n squared. So yeah, hopefully this made sense. I'm just iterating over each sublist and comparing the two adjacent elements because we already know they're in sorted order, and seeing if it's less than or equal to k. So hope this helped, and thank you for watching. Stay tuned for the next video.